With May the 4th recently behind us and thinking about Microsoft Fabric and PySpark notebooks, one common thread comes up consistently. What does performance look like between Pandas Dataframes and Spark Dataframes, that ever popular battle of the Dataframes? We answer that question today and give you some considerations to think about on today's chapter of DataBard. DataBard, 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 hoi, hoi, hoi. In presentations that I give on the topic PySpark and Microsoft Fabric, I often say praise be the data frame, because especially in Fabric, when you're working with your data, you want to get it into a data frame so you can make best use of the Spark capabilities and especially the extra bells and whistles that Fabric provides. But when I say that, I really should say praise be the data frames, because you do have two options. You have the Pandas data frame, which comes from the Python world, and you have the Spark data frame, which comes from the Spark world. What should you expect if we're going to use either one of these to work with our data in Fabric using PySpark? Here's the general answer. You should expect a performance difference between the two in certain cases. Probably the best way to showcase this is through a demo. So let's jump into a demo and I'll show you what this looks like and what to expect in Microsoft Fabric. So here we are in my Microsoft Fabric environment, and right now I'm going to showcase two notebooks, both of which are going to try and perform the same operation, but one uses a Pandas data frame, the other uses a Spark data frame. The use case isn't necessarily the greatest because we're not so much processing data, we're generating 100 million records for a particular file of about 9 columns wide, and we're going to save it off to a CSV. I chose saving it off to a CSV because, technically speaking, a Pandas data frame on its own is unable to write to Delta directly, which is the ideal storage solution we want to use in Fabric. So to try and keep it on common ground, we're using CSV. So generating 100 million records and saving it off to CSV, what do we think performance is going to look like? First of all, a quick clarification on my environment. I'm using the default settings here, and you can see here, more importantly, the compute that I'm using, which is I'm using the workspace default, and this is using a trial capacity, which means it's medium-sized nodes, 1 to 10 nodes with dynamic allocation. All right, so I ran this workload on this same Spark configuration, one with this Spark data frame, and a quick show you the other is my Pandas data frame, which does the exact same thing. Well, what do we expect in terms of performance? I'll show you the numbers and then let's explain. So, when running this process with Spark, I get a processing time of 54 seconds, just under a minute to generate 100 million records and put into a CSV file. When I look at the comparable processing time for Pandas, looky here, this took about, that was a bad scrolling. When I take a look at Pandas, take a look at this. It took 10 minutes to run to process the same thing. So what happened? Well, I think at least it's safe to say that between the two environments, Spark was able to successfully distribute across the 10 nodes, and because it was able to distribute across the 10 nodes, it was able to perform 10 times faster than Pandas. That's because with Pandas, Pandas is going to live in its own single node. That's all it can do. It can't do distribution without the help of other libraries. Now we hit 10 times performance with the Spark data frame in comparison to the Pandas data frame in a Spark cluster with 10 nodes. Is that coincidence or is that correlation? I haven't been able to 100% prove it, but I'd say with a fair amount of certainty, it's more than just coincidence. The distribution at this size of environment should be showcasing that the Spark data frame is actually distributing, this Pandas data frame is not. So what's the limitation on the Pandas data frame? Whatever your size of node is, which if you take a look at Microsoft documentation, a medium node I believe has 64 gigs of memory available. That's the maximum size really of data frame that you can work with in that environment. Depending on the capacity that you have, you might be able to provision larger nodes, in which case a Pandas data frame can go farther, but that is going to truly be the limitation. Pandas is going to be working for sure in a single node. Spark data frames will be able to work on multiple nodes. When your data gets to a certain size, you are going to want to move to that Spark data frame so you can make best use of distributed computing. That's not to say that Pandas can't be performant, and some people prefer working with Pandas because some of the utility it has available. I'll say at least with this experiment, I didn't start seeing a difference in performance until about somewhere between 1 million and 100 million records of generation was when the performance difference was significant between the two. Up until that point, you can probably work with both, provided that, again, the node size you're working with has the appropriate memory to store the data size that you're working with. As always, collecting more information about this is helpful. If you'd like to try out these scripts and see if you get similar performance or different performance to what I showcased in today's demo, check the link in the description for a GitHub repo that contains the notebooks that I showcased in today's demo. You should be able to upload them into your Fabric environment, and for the most part, they should run on their own. If you do end up using these and testing them out, please let me know your findings, as I would be curious to see if others have the same experience that I've had, or if the experience is different for them. So at least for right now, super large data frames, go with Spark. Smaller ones, it's about a horse apiece. That brings us to the end of today's video. Hopefully it's helpful, and I'll continue researching this to get a more definitive answer on the performance considerations. If this video is helpful, hit that like and subscribe button to be notified of future videos on the DataBar channel. And if you have any other questions about Spark, about SQL, or about any other things related to the data industry, please let me know in the comments. I'll do my best to answer them in future videos. For now, I'm DataBard, and I'll see you in the next chapter.